Saxon Advanced Mathematics. Hi, Jayla. These are the 5, I believe. Let me just flip to my list. You asked me, about 5 different homework problems that you were stuck on back through the past few, I was going to say episodes, but I really mean lessons. This is not a Netflix series. So let's dive in and do those. And it's going to require a little bit of shuffling around for me to be looking at the book and the solution manual and some of my notes. So be patient with me. The first problem that you asked about was from the homework 2918. And while I'm thinking of it and looking at that even number, I'm going to say, Jayla, don't do the evens anymore. Just do the odds. I don't want you to be strategic to avoid certain kinds of problems. Everyone else does the odds, so I'd like you to do the odds at all times from now on, okay? We'll turn over a new leaf for January. Okay, now this topic is about what we call quadrantal angles. And let me remind you of what those are. This is 0 degrees. This is 90 degrees. This is 180. This is 270. And then if we wanted to, we could come back around and say, well, this one is 360, right? And then we could add 90 again, and we could keep going around and around and adding. But we're not going to do that. We're just going to go around once. Okay, and what we've seen is that we can calculate values for sine and cosine depending on how big the angle is, right? Like right here, if this is 30 degrees, oh, we know how to do this. This is 60 degrees. And then we know the lengths of these sides, 2, 1, square root of 3. And we can find sine and cosine using these values. Using the same logic, we can find the value of the angles, like a 90-degree angle, which we can't really see because it lies right on top of that line. But we can find a 90-degree angle. We can find sine and cosine. We can find sine and cosine of a 180. We can find sine and cosine of a 270. We can find sine and cosine of a 0 or 360. All right? So what we're imagining is that the triangle is right at the edge of the quadrant. And that's why we call them the quadrantal angles, because they're angles that fall right on the edge of the quadrant. Now, in that lesson for I don't remember if it was 29 or not, but the lesson where we taught quadrantal angles, I gave you a big, long theoretical discussion of how they're derived. That just might have lost you. Okay, so let's not worry about how they're derived right now, because P.S., this is all going to tie in with our sinusoids, and I'm going to reveal that all to you in January. But this is how you can memorize them without quite so much drama. All right, so draw a chart. You know what? This is fine. Okay, so what I've got here is 3 rows, 4 columns. For each row, I'm going to write one of the trig functions: sine, cosine, and tangent. Here, I'm going to write the angle measurements of the 4 quadrant angles, right? 0 degrees, 90 degrees, 180 degrees, and 270 degrees. All right? Now, the value of sine ranges from 1 to -1 and sometimes hits 0. This is the pattern. Here, sine is 0. Up here, it's +1. Here, it's 0. And here, it's -1. Cosine here is +1. Do you see how it makes a really cool pattern? Right? 0, 1, 0, -1. 1, 0, -1, 0. And look what tangent does. Whoops. This stands for undefined. Okay, so tangent's kind of an oddball. He's got these wacky undefines in here. Sometimes he's at 0. We're not going to talk about tangent a whole lot. We're going to talk about sine and cosine a bunch. All right, so when you're finding the trig function for one of these angles, you can just refer to this chart. You don't have to draw out a triangle or anything like that. This is the chart that tells you the values of sine, cosine, and tangent at each of the quadrants when there's an angle that's right there. So let's look at, memorize this, write this in the cover of your book, make sure you have that handy, because right now you don't know how to figure that yourself, so you need to be really sure that you have this available to you. So the problem you are interested in is 2918, and it looks like this. Draw the necessary reference triangles and evaluate. Do not use a calculator. Okay, well, this one we really don't even need to draw the triangles because we have our chart. But 18 is 2 times the sine of 180 minus 3 times the cosine of 90 plus the cosine of 270. And let me just double check and make sure I copied that correctly. That's the problem itself. 2 times the sine minus 3 times the cosine of 90 plus cosine of 270. Okay, it's as simple as this. We recognize that these are quadrantal values, right? 90, 180, and 270. So we're going to refer to our chart to find the values. The expressions that have the leading coefficient, we'll just copy that, but then we'll use parentheses to say, okay, what's the sine at 180? Sine 180 is 0. Minus 3 times, okay, what's the cosine at 90 degrees? Cosine 90 degrees, oh, it's also 0. Huh. Plus, okay, this one doesn't have a coefficient, so we just find the cosine of 270, also 0. So it is 2 times 0 is 0, minus 3 times 0 is 0, plus 0. The answer for 2918, I'm looking in the book just to make sure I have it right. Yeah, the answer is 0. Done. Next problem is 3413. All right. Flip to that. 3413 says evaluate. Do not use a calculator. And there's A, B, and a C. Arc tangent of 1. Okay, so what this means is that we went to some angle, we don't know what it is, we drew a triangle, and we found tangent, which is over Arthur, and that was equal to 1. So it was positive 1 over 1, right? Just to draw that with more detail. So the tangent of some angle is equal to, it's over Arthur, and it was equal to 1 over 1. So what triangle would have given it that to us? Well, let's see. What triangle has opposite and adjacent sides that are both 1? Oh. Okay. It could be like this, right? Oh, that's not a very good one, but 45, 45, 90, right? And then we know this is 1, 1, square root of 2. Make sure you know your reference triangles inside out. You should have those burned into your brain. So, if we are limiting our answer to tangents either in the first quadrant or the fourth quadrant, right? Remember, we put those limitations on it, right? For sine, it's the first and the fourth quadrant. For cosine, it's the first and the second quadrant. And for tangent, it's the first and the fourth. And we write it as that's another way of saying it, right? Because this is 90 degrees and this is minus 90, right? Cosine is different because we have to take it in these two quadrants because cosine's positive down here in the fourth. So that we do positive 180. It's less than theta, it's less than 0. And then tangent is friends with sine. So what that tells us is we could be looking for a triangle that's down here in the fourth quadrant, but that would be a negative value, and this is positive. So that tells us that for this problem, the angle that gives us an inverse tangent, an arctan of 1, is a 45-degree angle. And I'm just checking, where am I? 3413. I'm just double checking the answer before I write it down so that I can take it back if I'm wrong. Yes, so the way we write the answer is that the arctangent of 1 equals 45 degrees. The angle whose tangent is 1, limited to either the first or the fourth quadrant, is 45 degrees. It's the only angle that will give us a tangent of 1. All right, let's try the next one. B. Now we're supposed to find the tangent of the arcsine of 3/5. Okay, so what that's saying is find an angle whose sine is 3/5. Find the degree measurement of that, and then find the tangent of that same triangle. Okay, that's what all of that means. We start with the innermost information and go on from there. So this one's a little trickier now because this doesn't relate to our reference triangle, but it's okay, we can figure it out. This tells us, because it's a positive value for sine, we know that we must be in the first quadrant, right? With these inverse trig functions, we always limit ourselves to just the two quadrants. That's why I keep talking about this. So we know that it must be in the first quadrant, and we know that it must be a cute little triangle like this. It's sine, so that's Oscar had. So we know that the hypotenuse must be 5, and the opposite side must be 3. We don't know this angle, but it's okay because if we can just figure out this side, we're going to be fine for finding the tangent because we'll have all three sides. Now, how can we figure out this side if we don't know that degree? Pythagorean. Right? If we square these two sides, they'll be equal to that one. So let's call this A, adjacent. A squared plus 3 squared equals 5 squared. A squared plus 9 equals 25. We subtract the 9. A squared equals 16. Oh, look at that. Take the square root. Can't be negative. A must be equal to 4. All right, fabulous. So what we did was we took this much information and we found all three sides of the triangle that this is describing. Now all we have to do is find the tangent of that same triangle. Tangent is over Arthur, and so that is opposite 3 over adjacent 4. So that is our answer. Let's hope. 3413. B. Yes, that's right. Okay, so we didn't even need to find the degrees. We just found the sides and kept building ratios from there. C. This one we are finding the cosine of the arctangent of -3. Okay, now for the first time, I'm sorry, I'm so crooked. For the first time, we have a negative value. What that tells us is that this triangle lies in the quadrant where tangent is negative and limited too. That tells us to use our limits. So here's my list. Okay, tangent is negative in the 4th quadrant. So that's where our triangle lies. Okay, it's down here because that's where we would find our negative tangent in this inverse function. So now we have to figure out, okay, tangent is over Arthur, right? So what kind of triangle would give us this value? It would be -3 over 1. That doesn't sound like any of our friends, does it? So what we're going to have to do is the same thing we did here. This is not one of our reference triangles. We have to just draw it, all right? So the opposite side is -3. So we're here. So our triangle is going to be like, I'm trying to make it proportional. I'm not going to worry about it too much. From here, the opposite is -3. That would be this side. And the adjacent is 1. All right? So just like here, we use the information that we have to draw it in based on what the sides are. We can't draw a reference triangle because these numbers don't show up on any of our reference triangles. That's how we knew they didn't work. So we draw in what we have. We use Pythagorean to fill in the missing information. In this case, we need the hypotenuse because we're trying to build cosine, right? And cosine is a hold. So we're going to need the adjacent. We've already got that, but we're also going to need hypotenuse. So we're going to use Pythagorean to get it. And that is going to be, let's see, we'll call this one A and we'll call this one B, and then our hypotenuse will be C. So this is going to be 1 squared plus -3 squared equals C squared. That'll be 1 plus, that's 9, right? And that equals C squared. And so we have 10 equals C squared. And so square root of 10 equals C. Make sense? Hypotenuse, we always use a positive value. We don't worry about negative signs. So this equals square root of 10. Now we're ready to build our cosine. Again, we don't need to know how many degrees are in this angle. We've already got the side, so we can just keep playing with the ratios. Adjacent over hypotenuse is going to be 1 over the square root of 10. And then we will rationalize that. So it'll become square root of 10 over 10 as our final answer. Let's see. Yay. Square root of 10 over 10. All right. So we use this to help us draw the triangle. We need Pythagorean theorem to put the finishing touches on it. And then we find the cosine using those sides. This is right. This is right. This is right. All right. Whew. Those are challenging. No question about it. Okay. That is the second problem. Get back to my list here. 35(4) is our next one. The engineer knows that the formula is T equals the square root of L over 4. All right? To get the desired result, she must triple her present value of T. What should she do to the present value of L? Okay, that's kind of a confusing question. What we're basically saying is this is her equation. She realizes that she has to triple this side. So what's going to happen to that L variable over here? All right, well, let's just take this one step at a time. If she's tripling T, The left side is easy, right? You just multiply it by 3t. So then she would have to multiply the whole other side, right? Okay. So what we did here is we just tripled both sides. They said to triple t, so we have to triple the other side too. Now what I want to do is I want to split these pigs. I want to get them out of their townhouse and give them each their own condo because that's just a little bit easier for my eye. So 3 times the square root of L over the square root of 4. We could fix this, but we don't really have to because all we're worried about is this, right? Okay, so what we want to do now is we want to take this 3 on the outside and we want to put it back inside the pig house next to the L. So we have to think about that. We don't usually go in this direction. Usually we're taking pigs out in pairs. So if we want to put it back in, that means we have to do the opposite, right? 2 on the inside equals 1 on the outside. So the opposite of that is 1 on the outside would equal 2 on the inside. So we would rewrite that as right? 1 on the outside equals 2 on the inside. So I wrote it as 3 squared, right? Now, if we wanted to simplify this, we would. We have 3 squared here, so we would pop it out as a single 3, right? So that we can test our work. So what that tells us, if we look at just this part of it, is that when we triple the t value, we increase L by 9 times L. Does that make sense? Let's see how John wrote it out. 35.4. She must multiply it by 9. Okay, so she must multiply L times 9. And John, here's the answer. John just left these guys in their townhouse. I don't like that presentation. It just looks confusing to me. I think it looks cleaner and neater to separate them. So that's why I did that. But our answer is the same. L ends up getting multiplied by 9. And if you wrote an explanation like that, that would be perfectly fine. Okay, that's number 3. Next problem, 39.25. What do you have in store for me this time? Oh, these are fun. They're so much easier than you think. All right, I'm not even going to write it on my paper. There's an A and a B. Okay, all you have, these are so much easier than you think. Let me explain how they work. We're supposed to find the domain and range of each function whose graph is shown. Notice that both of these functions have very distinct endpoints, right? There's a beginning and an ending. There's a beginning and an ending. All we have to do to find the domain is associated with the x-axis, right? So what we do is say, what's the highest value of x that we see in this picture, and what's the lowest? Okay, the highest value of x is 4, and the lowest value of x is -4. So we have to write that out now in fancy language, where we say the domain of x equals, x is an element of the real numbers such that, and I'm going to go to the second row just because I'm out of space. Or, yeah, I'll do it. Such that x is between -4 and 4. And I put the equal signs here because we can see there are solid dots at 4 and -4. So that means that point is included. So when I write my inequality, I want to be sure to include this and not just the inequality sign. Let me double check that. Oh, that's the domain. We have to do the range also. The range is y, sorry. 39, 25. I want to make sure that's right before we go on. X is an element of the reals. Yes, this is correct. Okay, now let's look at what's going on with the range. The range is always associated with y values. So we have to shift our focus. Before we were looking at the change in the x values. Now we're going to go this way. What's the highest value we see for the y's? It looks like it's right there at 3, doesn't it? Positive 3. And then the lowest value is right here at 0. So it's between 3 and 0 inclusive. So we say that the range of y is the set of real numbers. Y is the set of real numbers such that 0 is less than or equal to y is less than or equal to 3. And I'm double checking, yes. Okay. B, we're going to do the same thing. For x, right, we look for the highest x value. That's at 2. The lowest one is -5. And then we switch and we look at the y's. That goes from 5 to -4. So we write it out using John's super nifty, well, it's not John's, but we use the super nifty notation. Just a second. Domain of x equals such that it was between -5 and 2, right? Right, and we just got it from looking at the picture. That's how easy it is. And the range of y is that y was an element of the real numbers such that, let's see, that ranged from -4 to, it was +5. Okay, this should have a pointy thing. So there's the domain and range for the second picture. So you are literally just looking at the picture and finding the highest value for x, the lowest value for x. That gives you the domain information. And then range is always associated with y. So we do the same thing, just looking up and down. Da, 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 da. $39.25 is done. We have one more, 40.21. Fresh piece of paper. There it is. Evaluate. Do not use a calculator. 21. A is, we're supposed to find the angle whose tangent is -√3. And then we're supposed to find the cosine of the angle whose tangent is -2/3. Okay, these are similar to the ones that we did a few minutes ago. I don't remember. Ah! I'm dropping books. I've got stuff all over my lap and papers heaped on top of the dog. After I finish a problem, I flip it over on the couch next to my dog. It is quite a process I go through to help you with these problems. I am happy to do it. 40.21. Oh. All right. So we have to try to figure out what triangle this would be. Maybe we're going to just make up a triangle and use it like we did in those other problems where we use Pythagorean. Let me show you. In these two problems, we never actually found a degree measurement here. We just figured out what the triangle looked like, and then we used it to find a new function. But this one, this problem looks more like this, doesn't it? Where we just have that and a value. This one looks like these other ones. So let's see if there's a reference triangle that would give us this tangent. Tangent is over Arthur, right? And again, we're being given the value of the decimal, if you will, only we're getting it in square root form. But we don't know the degrees. So let's see if we can figure it out, though. It's minus, and this tells us that we're in the, there's only two quadrants to choose from. I wrote them down over here. Tangent is the first and the fourth. So this is negative, so that tells us it's got to be in the fourth quadrant. Square root of 3 over 1. There is a triangle that would have the square root of 3, right? It's the 30, 60, 90, right? 30 here, 60 here. This is how we chopped it. 2, 1, square root of 3. So this side would have to be the opposite side, right? So this would have to be the square root of 3 over here. And this is the hypotenuse. So that's where the 2 is. And then this would be the 1, that's the adjacent, right? So what I'm doing, just so you understand what's going on inside my brain, I recognize from this that it's a 30, 60, 90 triangle. But I don't know if we need the 30-degree part of it or the 60-degree part of it, because I'm not sure how that triangle needs to be oriented. So I drew the triangle here and just let myself look at it and said, okay, if I want the opposite side to be the square root of 3, then this has to be over here. And this then would become the adjacent. And so I drew that up there. Does that make sense? Now I just have to figure out which angle goes here. That would be the 60 degree. So the answer to this problem should be, oh, I'm in lesson 16 because my book fell. Thank you, Grace. She's lying down on top of all of my papers. Yes. So this is the angle that gives us an arc tangent of minus square root of 3. So it's a minus 60 degrees. The arc tangent, the angle whose tangent is minus square root of 3 is minus 60 degrees. Okay, and we drew a picture of it right there. Beautiful. Okay, now we're going to try to do the same thing over here. Except when we look at this, we go, right away we can go, okay, there is no reference triangle. Tangent, again, is over Arthur. There is no triangle that has an opposite side of 2 and adjacent side of 3. That's not either of our reference triangles. So we know this isn't going to be a reference triangle, all right? And so we know, okay, we're going to be making this up. Now, we do know that it's negative tangent. And we know, oh, Gracie's lying on it. Can I get it out? It's buried under her belly. We know that when we're talking about the inverse functions, tangent goes between minus 90 and positive 90. That's fourth quadrant. And first quadrant. So we know, my books are falling all over. We know it's down here because it's negative. We know that the opposite side has to be 2, and we know that the adjacent side has to be 3. So we know that our triangle must look like that. right? And we know that this has a negative value because it's down. So in order to find cosine, we're going to need the adjacent, which we've got, but we need the hypotenuse. So how are we going to find the length of this hypotenuse? Pythagorean. So we know a squared plus b squared equals c squared. These will be our a and b. So it's going to be, I'm just going to square them in my head. 3 squared is 9, minus 2 squared is 4, right? And now we need to take c equals the square root of 13, right? So that's the length of that side. Now we've got what we need to build the cosine of this same triangle. And yes. Okay, so we need adjacent over hypotenuse. Adjacent is 3. Hypotenuse is square root of 13. It's negative. No, it's positive because cosine is positive down in the 4th quadrant, right? We can do a quick check of that with our chart. Whoops. Cosine is positive down here. So it's positive value right here. All we have to do now is rationalize the denominator. So our final answer is that it's 3 times the square root of 13 over 13 positive. There's the positive, and let me just check that. 21b, 3 times the square root of 13 over 13. Yay, there it is. Okay, this problem, 4021, was a whole lot like one of the other ones that we did. So you really just had 4 different questions and not 5. All right. I hope this helped you, Jayla. What I really would like you to do is set whatever notes you just took aside and try to do these problems again in your homework paper, on the actual paper where your homework is. Copying them from me is not the same thing as doing them yourself. And even if you just click pause on the video and turn right around and do them in your book, that's different than just copying what I put into your answers. So please do this with integrity so that you're actually learning from it. And just a reminder, from now on, it's odds only, girlfriend. No picking and choosing. Okay, beautiful. Thank you. Let me know if this helps. Bye.